Hello everybody and welcome back to the channel and to yet another tutorial where we are going to be building an agentic AI software for investment professionals. And here's just a high-level pitch, and then subsequently in the next few minutes we're actually going to be building it step by step without any coding experience. We're using Versal v0 as well as N8N. The pitch is basically all these public investors, they're reading all these countless of PDF documents, and ideally we would want to have it interacted with a chatbot once again that these financial analysts can basically be just asking questions as opposed to reading all these PDFs and then doing all the reasoning, if that is a good investment in the first place. Of course, you can technically be also using the search feature within these PDFs or using different types of large language models, but it's hardly ever integrated into one entire software, and that's exactly what we're going to be building. Now, I already prepared the initial prompt here, but before we get started into the actual build, my name is Cyril, and on this channel, once again, we do these tutorials, and we also have a podcast where we are sharing our day-to-day learning, building AI products since 2023. Back then, we were building image systems. We have thousands of clients actually using these software as a services, but probably like everybody else in the meantime, we did pivot to more agentic software, doing it securely, running on a cloud. I have a little bit of a detailed overview also how you actually be running it super securely, but maybe I'll probably save that for a separate video. Here's just a high-level overview of how you can actually be running it super securely, and then we are going to be building it a little bit less secure on N8N. But here are just the actual components, because I was asked by one of you guys in the audience, how could a super sophisticated modern system could look like, especially if built for finance. And here it is, just a few seconds. If you're not super interested in that, maybe you can just put forward, and then we can actually be starting with a build in the first place. But for whoever is interested in these security topics, here are just a few nuanced caveats where you actually be needing to be aware of these dynamics when you actually build artificial intelligence-based systems. We have the model owners, we have the service providers, and we also have the data owners. The data owners is us, as for example, investors, as financial analysts. We don't want our data necessarily to be sitting around in some public cloud, and maybe other people can actually be accessing it. For the particular use case today, we use public PDFs. That is not a problem, but maybe you have actually client identifying data or some other sensitive data lying around. Again, you do not want to use, for example, just simply Claude or ChatGPT. That's something to be aware of. We also have the model owners. In today's tutorial, we're going to be building a retrieval augmented generation pipeline on N8N, and we're going to be using OpenAI model setups. You can also be using Anthropic setup. The idea is these model owners, many of you are aware maybe by the brands, but they're actually not running many of the services themselves. These models are sitting in some service provider, for example, AWS, for example, Google Cloud or Azure. All that stuff is fairly super securely stored and encrypted, but just intuitively, us as a company that we're actually building this particular element, again, an AI SaaS for investment professionals, we need to rely on the service provider. The service provider needs to rely on the model providers and the model owner. So that's a little bit of the triangulation actually. Yes, ideally, and that's exactly where I wanted to put the focus on this particular slide, is we give the model inputs, for example, the PDFs or some questions around the PDF. This is super confidentially secured in a particular domain, for example, within AWS, and it's then sent back as model output, displayed on our user interface. Where all that stuff is sitting is highly dependent on the security standards. Again, if it's on N8N or for simplicity reason on Versal v0, we don't need to worry too much about that. But once we go into finance, we go into banking, all these considerations are becoming incredibly important. There's particular services, for example, by AWS, I'll put it on the screen, called AWS Nitro Enclaves, where exactly this service is actually happening. Quick shout out also to the Anthropic research team for displaying all that in the confidential inference system paper published this summer in June 2025. But let me quickly go back to the actual build. This was super secure. Now let's build a little bit less secure, but you can still prototype, get feedback, and then launch it a lot securely when you actually have traction on your particular prototype. Now, what we're actually going to build, I teased it multiple times, don't have to retry too much, but the prompt I'm actually going to use, please use React Versal v0. This is a fully no-code tool. It helps sometimes to actually be specifying which type of library or which type of stack it should actually be using. The backend is Java Spring Boot. That's generally speaking super secure. Then we have a few UI components. We have a home, an AI analyst, my assets, and taxes. Generally speaking, a great practice if you have an investing tool to also have some sort of tax filing capabilities. You can leave it away if it's too complex and you don't seem to have a need for it. I also gave it an attachment. You can do that on Versal v0. It actually helps to streamline the design processes. I simply downloaded 2 very simple UI screenshots from Coinbase. I'm fully aware this is a crypto platform and we're building an investment AI SaaS, yet I kind of like the UX of Coinbase. While this is running, gave it a shoot. This should generally take between 2 to 3 minutes. This particular process here is not free. You can actually be using Versal v0 also with the code in the description of the video. You get $20 worth of compute tokens fully for free if you sign up on Versal v0. That's exactly the no-code builder I'm using here. There are also some other ones, for example, Replit or Versal. I just happen to really like the security and the configuration on Versal v0. To me, at least, it seems to be the most state-of-the-art to build for finance and to build also for more advanced corporations. While this is running, let me quickly switch back to the AI engine. Ideally, once again, we would want to give the artificial intelligence chatbot, aka our software, a vast array of documents. And instead of all these investors reading through these documents manually and maybe doing some markings, maybe doing some search operations within the PDF, we would want to give them the capability to ask the chatbot, and then the chatbot goes in the PDF and basically looks for the information, spits it back out, and then again, the analyst can go back and forth and reason through if the investment makes sense and or they need to sell a particular stock. So that's a little bit the high-level intuition. For this, we need 2 particular elements in artificial intelligence. We first need the chatbot component, which basically takes the message from the user in the chat UI, TBD if that's going to be built nicely in a second on Versal v0. The second component is we need all these PDFs, or in our prototype case today, this one PDF, we need to transform it in a way that is retrievable by a large language model. And I'm going to spend 1 or 2 minutes explaining this process, this actual sometimes cumbersome process, why we need to do it in this place, and also how we do it on n8n with a few clicks. Once again, n8n, if you're completely new, is a no-code AI agent builder. It's a drag-and-drop way of actually building it, but still, you need to configure a lot of credentials and you need to configure a lot of external platforms for it to actually work. And that's exactly the topic of this particular tutorial as well. I'm going to talk about how to set it up, but also I'm going to talk about how to actually connect all these elements together for us to then send a message on the UI and then basically ship it to n8n, do the computation, doing inference, in other words, and then basically send the answer back. We also check, of course, if the answer makes sense or the LLM just hallucinated something in the first place. Before we get into the n8n workflow, let me quickly check back into Versal v0 and just one or two words. Generally speaking, sometimes Versal v0 asks a question back. So always be aware of these questions. Sometimes it asks which design pattern should we use. Maybe if there is a back-end component that it should already bake in to the actual initial code, and so on and so forth. There is this back and forth just on Versal v0. If you're completely new to Versal v0, I have some other tutorials just explaining how it more or less works. Again, it is fully no code, but also you can have more and more integrations into it. Today, we don't touch any of these integrations. We basically just let it write the code, and everything else we build by ourselves. The benefit basically of building it by ourselves, once again, is we have a lot more control over how we can actually build n8n. Now, let me quickly spend some time first on the database, and then I will spend time on the agent that's just basically taking the question and then sending back the answer. As for example, I'm quickly zooming in here. Ideally, we would want to have a PDF. We need to upload it on Google Drive or any database. In the case of a corporate setting, we probably will not use Google Drive. We might use a particular more sophisticated database or just a file uploader. Basically, it might be a little bit more secure. But in our simple example, we use Google Drive. Then basically what we are doing, we're taking this PDF, and the PDF, just to basically also show how this actually looks like, is the Microsoft filing of just a few days ago, because the quarterly period ended 30th of September. All these large companies, they're filing these 10Q filings. And the reason why I actually chose that, it can't possibly be that these LLMs already know that domain knowledge, because that stuff has just been out for a few hours. And we can actually see if our retrieval augmented generation pipeline, meaning our RAG, is actually working properly. This is 67 pages. And as you can see, of course, it has a lot of tables. It has some sort of comments on the market. If, for example, Microsoft is expected to increase revenue or decrease revenue, it of course has some geopolitical risk. Probably there is some nuanced understanding of OpenAI's partnership and so on and so forth. I actually haven't read it myself because, again, we're building this tool for it to answer all the questions we might have about the document. So that's exactly the document that I'm having. The first step we have to do, very simply, download the document, and then we have to upload it on Google Drive. Very simply, if you're running on a Mac, you can have Google Drive locally running on your machine. Very simple first step, take the PDF document and put it into Google Drive. So that's really the first task you have to accomplish. And then if you go back to N8N, the first workflow or the first step we actually have to open is the download file of Google Drive. So basically, if you go to Google Drive, and then there's all this array of actions, you can go to download file. That's exactly the one you would be using. You can also use some other ones, for example, for other use cases like copy, like create a folder, and so on and so forth. Maybe if you do some automation on that sense, but for us, we just need the download file. Then, ideally, you would have set up the Google Drive account for that particular element to be set up. I will probably do a separate video of how this actually is working. If you have it already set up, meaning you already have some sort of connection on N8N, the only thing you would be needing to use is use a download operation, and from the list, you have to select the particular PDF document. That's exactly what you need to do. The only thing, again, that can actually be helping you, of course, just to set it up very, very briefly, is there is on N8N documentation overview. If you can go down, you will basically see all the templates and the way you would set it up. For that, you would need ideally a Google Cloud account, which is basically here. So let me quickly still walk you through a few of the caveats and elements, because this particular Google Cloud account sometimes is changing in the sense that the UI, there is new features. Initially, you need to log into your Google Cloud account. That's the first thing you need to do. Then under branding, you can give it a name. You can use the support email address, which is basically your Google Cloud account. If you go further down, the authorization name, and then also you need to give it a developer contact information. Sometimes this is already indicated here. In the audience, the only thing you need to do is use a test user, so add user and add yourself. In the clients, once again, you would set up the client in a sense that this client ID is then exactly the ones you would configure in N8N. There will be a particular button where it says client ID. That's the one you need to copy. And data accesses, you do not need to set up anything. On verification, once again as well, settings, you don't need anything. And then you can go to Google Drive, basically, and click on Google Drive, and then should be an activation button. Here, I already have it activated or enabled. In your case, it might actually be enable this particular one. And then it says API is enabled. If you follow all these steps, step by step here on Google Cloud, again, this particular Google Drive account is connected. You might actually need to connect it and then log in once again here on N8N. I actually already did that. And again, you can basically be selecting file, download, and from the list, you can then select the particular file you actually want to be working with. Once again, this is one file, one PDF, in our case, the Microsoft report. That's exactly the first thing you would need to set up. Then let me spend some time reasoning through the Supabase vector storage. It would be a unique idea if large language models can simply interact with an entire PDF document. But for simplicity reasons or for complexity to train LLMs, this is just simply not the case. Large language models have some sort of different way of interacting with data, as they're trained on tokens, meaning input tokens to be trained, and output tokens, they anyway have a little bit of a different vocabulary sometimes, and they're actually not using text, they're using tokens. That's a completely different story. But for this particular element, we would want to use the PDF document. We would want to chunk it, so basically split it into different parts and portions. Maybe I can put an image on the screen on chunking, and then we take these chunks and we put them into a multidimensional or even hyperdimensional space called embedding space. So we take the chunks, we shoot them into the vector storage, but the vector storage itself is not some simple 2D space, it's a multidimensional space. And in this multidimensional space, the LLM can then go and check, for example, and take back information out of this multidimensional space. This is called embedding space, and the whole process is basically take a PDF, chunk it, use an embedding model for it to put into this embedding space. Embeddings are vectors, and you'll see that in a second just on Supabase, how they could look like very, very simply. There's a very complex, sometimes chains of work, how you can actually embed certain elements, which embedding models you use, how you can actually optimize it, and so on and so forth. For this tutorial and simplicity reasons as well, we just use a very simple embedding model by OpenAI. And that's the second quick component I'm going to talk about before we set up Supabase. So once you have the Supabase vector store, once again, you can go here and put vector, we can put Supabase vector storage, or just simply put in vector storage. You will add this particular element. In that particular element, we're going to set up Supabase just in a second, and you can actually be connecting the embedding model into this particular Supabase vector storage. So if you add a particular embedding model, it will basically be saying, okay, which embedding model do you want to add onto it? There's a vast array of embedding models we can choose. Once again, the embedding model basically takes the chunks, puts them into the embedding space. That's exactly the only operation the embedding model is used for. There is better embedding models and there is worse embedding models. This particular embedding model is kind of okay. We use text embedding 3 small by OpenAI. If you haven't set up OpenAI, once again, you can click on Docs. There is some explanation to it. The easier way of actually doing it, we need to simply connect the OpenAI account to N8N, and then once that is connected, we have the API keys in N8N already enabled. We can then basically be selecting the text embedding 3 small model. The way you would actually go to check for the keys on OpenAI is you basically go to platform.openai.com. In this platform, this is not the ChatGPT interface, it's a separate platform for it to manage the API keys. You can see here on the left, API keys. So I just put myself there as well, API keys. You would click on these API keys, you would generate a new one, and then you can basically be connecting within N8N your OpenAI account. Once you have done that, you can then basically be selecting the embedding model that we are going to be using. Again, there's a vast array of embedding models. We just use the small one for that particular use case. There's also some more options, for example, if you're interested, just to basically be doing some more fine-tuning on embeddings, but for the simplicity of this particular tutorial, we do not do that. Secondly, you also need a default data loader. Don't worry too much about it. The only thing you actually have to do, since this is not a JSON or a schema, you actually have to change the type of data to binary. So we use binary data for this particular data loader, load all input data, and text splitting is simple. You can also basically be saying, okay, we do some more advanced splits, or for example, but we do not do that for this particular tutorial. Then keep in mind, this embedding model we also need to use for the retriever later on. So this particular line here, you also have to actually be then connecting later on to the vector storage in the first place. We recycle the same embedding later on as well. So that's a small caveat. Now we have it tucked into Supabase vector storage, and then later on we will also use it for the tool call when we are actually answering the question or we want to retrieve information from this particular vector storage. Now here's the rather complicated, actually super easy part, how we actually set up the Supabase vector storage. This is the module. Yet again, as with everything on N8N, we need to set it up with the credentials. Once we have set that up, it's actually fairly simple to then simply connect it, generate the table, or in other words, the vector storage, the database, and then fill the database with all the vectors coming from the embedding model. That's exactly what the next steps are. If you again haven't set that up, there is again a link to the docs of that particular Supabase vector storage node. As always, with these elements, there is a quick start for setting up your vector storage. So depending on when you actually are watching the video, this might actually be changing ongoingly. That's why it sometimes is helpful to not only watch the YouTube video, but click on the link, because some of these elements might have changed. Maybe Supabase had some updates and we need to actually now use a different command to actually generate the table. There's two different ways. You can either copy directly the SQL command here, or you can go to dashboard. So switch to dashboard, go to SQL queue editor in the dashboard, then click LangChain in the quick start section and click run. I just figured out that sometimes this SQL works, sometimes it didn't. So I usually went for the dashboard option, which is generally speaking always working because it's basically interlinked within Supabase in the first place. So you can go to Supabase. Again, Supabase, you need an account, you need to set yourself up, you need to create a project first. So just basically generate the project. Then based on this project, you will see here on the left, you see project overview, and it's exactly where you're landing, project overview, table editor, and SQL editor. Here's basically already the table that is already filled in with the vectors and the embeddings. Now, the way we'd actually set it up, what we just saw in the quick start guide, is go to SQL editor, go to quick starts within the community, and the code will already be displayed once you click on LangChain. LangChain is a popular Python framework, for example, for everything AI. You can also be using LangChain for building multi-agent systems and so on and so forth. So LangChain is fairly a cool library if you want to do a little bit more engineering into artificial intelligence. Now we would just basically be going to LangChain, and as already plugged that in, so I do not execute this particular command, but in your case, if you're running on a Mac, you can basically be just running command enter, and it runs the code. And what the code does, very just high level, it's creating the table called documents. So basically, this is the vector storage that it's going to be created into Supabase. And here's just a little bit more code of basically which type of table and so on and so forth, what are the IDs, the keys, and so on and so forth. So do not worry too much about it. You don't have to change any of the code. Quickly just go on quick starts, LangChain, run the command, and then what should happen ideally on your table editor here on the left side, here is the table. In your case, when you just set it up, the table, of course, is empty. So the way you would fill the table, or basically do the embeddings, is by executing the node here on N8N. So it would basically be just executing the node, and then it would take the embedding model, and it would actually inject all the embeddings from the PDF that we uploaded on Google Drive into Supabase. So that's exactly what the process would be doing. The way this actually works, and you can see here as well, is you then see, for example, all the entries that we did in terms of embedding. So this is exactly the way the embedding model by OpenAI did the vectorization or the embedding space fill up, basically. And you can see also the content. Sometimes this makes sense and sometimes this really doesn't make any sense, but it's really the language of the LLM to then retrieve the information from the vector storage, which is, again, in other words, retrieval augmented generation. Now, let's quickly go back to N8N and see what is left. Once again, we set that up here already. So the embedding, meaning everything that we took from the document to the vector storage, is fully set up. The only thing left that I'm going to spend the remainder of the N8N tutorial here is talking about the webhook and talking about the agent and then the tool call to the vector storage. Yet again, we probably need a chat model, but that's TBD just in a second. Let's go back to Versal V0 and see where we are currently in terms of the build. This is the first time that I'm actually seeing this UI. So sometimes you might have a positive surprise, sometimes you might have a negative surprise. Let's quickly walk through. It actually looks pretty okay from the first point of view. We have the home, we have the total portfolio value. Just to reiterate, we are building an AI SaaS for investors. So most likely they're interested on a dashboard where their portfolio value is roughly $850,000. We have the agent, which is actually looking pretty unique and pretty modern-ish, other than the chat bar, but we can easily iterate over the chat bar. We have the assets, which we also see. Again, you're a technology investor or you're a portfolio manager, you're an investment analyst. You would want to have some sort of overview on P&L, and you can connect that to maybe an external database. And we have the tax filing. Of course, some countries, probably most countries, they actually have capital gains tax. I'm from Switzerland, we don't have that, but many other countries, they do have capital gains. And ideally, we would want to have some sort of mechanism based on the capital gains. How much tax are we owing? So again, linking a tax, some sort of feature into an agentic AI systems, or like in this particular one, an AI SaaS for investment analysts, might be a needy and handy tool actually to have in the first place. Now, again, ideally, the analysts, they would be interacting with this chat bar. They would be asking questions around PDFs. They might be asking questions about general practices on investing, maybe some market outlooks. And then the agent would actually do tool calling. It maybe have a browsing capability to go on the open internet. It maybe has a capability, for example, on docking to other databases, like, for example, external data sources. And again, it might have the capability to retrieve information from PDF documents. That's exactly what we have been building so far in the last few minutes on N8N. So the way we would actually be connecting these particular elements, meaning the AI agent software or built on Versal v0 to our N8N workflow, is actually fairly simple. We have a webhook. So that's another node that you can basically be simply adding as a webhook. There's nothing that you need specifically. The only thing we would need to change quickly is me to stop listening. So let me quickly do a reload. Sometimes these elements are getting stuck on an N8N. Hardly ever happens, but in this particular case, it did. Then the webhook I was talking about, again, very simple. You get the URL that we need to basically give Versal v0 to then send all the information, meaning the chat message, to N8N. The only thing we have to change here in the webhook is you usually have it under get. We need to have it as post. We also have a path. Do not worry too much about it. And as a response, by default, it's usually immediately. We need to say using the respond webhook node. What it does basically is once we receive the webhook, the large language model goes into the vector storage, tries to look for the information, then spits it back out as a response to webhook, and then spits it back to Versal v0. That's exactly what we want with this configuration. Now, let's quickly tell Versal v0, please, and that sometimes doesn't work, so we need multiple iterations. Please, in the AI analyst chat, when the user is asking a question in the chat box, send the question to this host webhook. Pretty much it, because sometimes the Versal v0 already built basically a baked-in version of its own artificial intelligence agent system. I specifically told it at the very beginning with a prompt, it shouldn't be doing that. Sometimes it still does. And when we then use webhooks from N8N or any other domain, it sometimes gets a little bit confused and it just overrides its entire basic AI capability that it built before. So we need to be very specific that this is a post webhook. It's coming from a different domain. It's not within Versal v0. So Versal v0, we don't care that it actually already built some agentic capability into it, basically. So let's see if that is already working. And we can basically be doing that by listen to the event. Basically, we can do that here. We can test if we actually receive a particular question. We can just run a test and it basically says, yes, it was executed successfully. And we saw it here in the body, the question came in, which is basically saying, yes, the connection from Versal v0 to N8N has been working. Now, in the AI agent that we haven't set up yet, we need to quickly check on the schema which element, and I have to remove that here quickly, is the actual message coming from the user. In some cases, it is called message. In this particular one, it is called question. So we actually have to tell in the prompt here, look for the question that's coming from the user. That's basically the way it configured it. The only second thing we can also do is you can go here to options, and I already did that here. I will quickly delete it again. You can use a system message. Once we set up the agent, receives, for example, the prompt, meaning the question, but above the prompt itself, meaning the user prompt, we can give it a system message, or in other words, a system prompt. It's like the meta level of setting the AI agent into a particular mood. And this mood is you are a professional financial analyst answering questions about complex investments, give general information. You might actually add this particular system prompt to be super complex, many hundreds of lines, but for this simplicity, we just say this is more or less enough. We can close this particular AI agent once again. We configured the webhook. We did configure the AI agent just now. The only left thing to do is two things. We need to also give a brain to the AI agent, and the way we do it, very similar to the embedding model before, we link it to an OpenAI chat model. Back in the day, for example, for another tutorial, we used Anthropic models. Now we're actually using OpenAI chat models. The good thing is our OpenAI account, ideally, because we did configure the embedding model, is already connected. So the only thing we have to do is we'd have to choose a model from the list. If it's a super complex query, for example, we might, for example, be using a more state-of-the-art AI, for example, a GPT-5 or a 4.0, for example. But in this particular case, 4.1 should be sufficient to do most of the heavy lifting. If you do financial analysis, generally speaking, probably Anthropic is a better model choice. But for this tutorial, again, completely arbitrary. Also, if the questions are super fast, we don't want to have a slow model that's super expensive and costs a lot of money in terms of token input and output. We would want to have a fast, cheap model that just answers the question, and we're basically get a response back very fast on the chat UI. So that's it for the chatbot. Once again, the only left thing to do is you can see here as a tool, because it shouldn't be only answering questions via what it already knows, being publicly trained. Again, it should also be going into the Supabase vector storage and look for the data we actually set up in the vector storage in the first place. So again, you would use a tool, you would use Supabase vector store once again. And the only element we have to tell it basically in the description is the AI agent actually has to call this tool to look up more information from, for example, the Microsoft quarterly report, or generally speaking, this particular message has to be more generic if we have different types of data sources. But in this particular case, we already know, if the user is asking a question about Microsoft, we can basically be saying it has to execute this tool. The way tool calling sometimes is in practice, especially if you have more complex system, is actually a little bit more tricky. We would not want to do it very specifically like we did now. Again, for simplicity reason, we can, every time there is some sort of question on Microsoft, again, it should be basically saying, I have to call the tool. Meaning the tool call would then basically be saying the large language model has access to the Supabase vector storage. With the AI agent's understanding of vectors and embeddings, it can go into this vector space and basically retrieve information from this deal document or for this PDF document. That's exactly the mechanism we set up now. It's not only smart because it actually has a large language model tied to it, it also has domain-specific knowledge coming from a PDF. And that's exactly the feature we would want to have it engineered for our agentic AI software. That's exactly what we have to do. We also have to do basically connect the Supabase vector storage to the embedding model once again. So that's the last link we have to do. So this particular arrow is also important. And then lastly, what we have to do just before we wrap up this particular tutorial and go back to the Versal v0 front end is we have to set up the respond to Webhook. Super simple node. You can say basically be simply going to plus here and look for respond to Webhook. Just add that. And again, what it does is it receives the webhook. The AI agent is analyzing the request or the body message as a chat box. It goes into the vector storage, looks for the information, and then ships it back to Versal v0. Now, let's see if that is already working, or we actually have to do one more prompt, meaning we have to tell Versal v0 it should wait for the response of the webhook, but it maybe potentially is already working. And we ask now a little bit a difficult question, for example, on cloud. For example, let's just go through what exactly is it we could ask. Ideally, it should be something that the large language model doesn't yet know, something maybe from the highlights. If I just quickly go and look for some particularly unique elements. Ideally, you can also ask it questions on the tables, for example, but we will not be doing that just yet. Maybe we can try it in a second. Exactly. So we would want to ask it this particular question. Highlights from the first quarter of fiscal year 2026 compared to the first quarter. The question we're going to ask is actually super specific. We're going to ask by how much did the Microsoft 365 commercial cloud revenue increase? Or actually, we're going to ask this particular question. Microsoft cloud revenue increased by 26% to 49.1 billion from 2025 to 2026. It's something that the large language model, being the brain of us, certainly doesn't know. And it has to come from the retrieval augmented generation. And that's exactly how we can test it if it actually gets it right in the first place. We have not done any other tweaking. We just set it up on an 8N. This is fully out of the box, fully no code. In practice, you would have to engineer probably back and forth a little bit. So let's see if we get lucky and we can ask this question and it already knows and does the retrieval augmented generation correctly. So let's go back to Versal v0. And I'm just going to double check. Please make sure to listen to the response and display it as answer to the chat message. Sometimes it already sets it up in that particular way already, and we just haven't tested it yet. So I'd rather give it a double check to Versal v0. Make sure again, once we send the message, it goes through N8N, and we'll see that visually just in a second. It then brings it back to this particular UI as a response. Sometimes it does it, sometimes it just literally doesn't do it, and we have to again do this particular prompt. I just did it at this very second. Now, again, while this is running, maybe I can quickly already put the message into the chat window, and then we can see if our retrieval augmented generation is actually working. So the question is, what are the highlights from the first quarter of fiscal year 2026 compared to the first quarter of 2025? And we're going to be basically saying by how much in percentage and in USD did the Microsoft Cloud revenue increase from, and the question is from the first quarter of fiscal year 2025 to the first quarter of fiscal year 2026. So that's basically the deviation that the AI should do, increase from the first quarter of fiscal year compared with the first quarter of 2025. So that's the question we're going to be asking the LLM or our N8N system. Once again, let's see if that is working. For us to execute this particular workflow, we would have to execute the workflow. We would have to set it up. So now it's live. Let's send the question. And then what we can see here, it basically took the webhook. The large language model goes through the vector storage, and ideally we should see the answer here. Of course, we didn't. So the UI itself doesn't display it correctly, but the percentage is actually correct. So I see the output here in N8N to be correct. I just need to basically be saying, listen, the output from N8N is, that is not displayed on the screen in my chat message. Basically, I hardly ever had one situation where it got it right in the first place, because again, it most likely configured it in a sense that it had some sort of internal AI engine, and now we have to replace it with an external one. But that's exactly what I was saying at the beginning. We would want to use N8N because we have some sort of more customization features and we have some more observability features, as opposed to simply using Versal v0 and its own agentic capabilities. So we actually see it is working. So retrieval augmented generation based on a Microsoft deal document is working just technically. The large language model goes into vector storage, looks for exactly this particular question, this particular component, the 26% increase. It's exactly what it had here. 26% increase, 49.1 billion, which is exactly the correct amount it came up with. And so technically speaking, the retrieval was actually working. The generation was also working, coming from the large language model. And now we are dealing with a problem on a UI component only. And we just need to fix that quickly, as opposed to, again, relying on a UI that doesn't work yet. So the question was, I need to re-ask the question once again. Probably save that somewhere if it still doesn't work. By how much did the Microsoft revenue increase in percentage and in USD? And then again, we have to basically be saying, listen, we are interested in the first quarter 2025 to the first quarter 2026. And also, of course, it depends how you ask the question. If the question is very badly formulated, of course, it actually is not working. So let's see if that is working. In order for it to work, we again need to execute the Versal v0 workflow. It will start listening to the message. It will then go through the entire retrieval. Once again, it now does the generation. It sends it back. And we again have an error. So it probably was another error actually happening. So basically, it's just mostly a front-end issue. I might iterate here for 5 or 6 or 7 more times But generally speaking, it should basically be just taking the N8 N output, which we were able to do just in very simple no-code terms, and display it here on the UI on Versal v0 for the user then to ask maybe a follow-up question on a particular question. While this is running, the only left element to be saying is that, again, once you would be having multiple documents, multiple types of PDFs, maybe some are scanned, some are not scanned, some are, for example, more complicated data, for example, in an Excel table, or in a table in itself in the PDF document, you would want to have a more advanced system, again, especially if the data you're actually analyzing has to be secured in a very specific manner, as we talked about in the beginning. So let me just finally check it one more time. Otherwise, I probably would need to do a few more checks here just on the UI on this vibe coding fashion. Again, goes through the retrieval, goes through the generation, responds to the webhook. That has never been the problem so far. The problem, as always, has just been on the UI component. Some particular prompt, if you actually are having the same issue, is go into deep research mode, try to really condense everything into smaller problems, and then reason through and solve this particular issue. That's exactly what I'm giving it once again. Should go back. Again, it should basically be simply taking the response to the webhook and display it here. Sometimes it's a dead end with vibe coding. Sometimes it really, really works. Usually we're on V5 of the build, which is actually, generally speaking, very fast. Sometimes we're at V50 and we are reaching these problems. So let me check back just in a few seconds when I actually got that fixed. Hopefully it doesn't take me too long. Just in a second. So then we are back into a fully functioning Versal v0. I just had to shoot a few more prompts. At some point I got frustrated, so we had v7. So basically it took 2 iterations. It was actually just a matter of a few seconds until it got fixed. Sometimes Versal v0 and these coding agents, they really overcomplicate elements. So you can also copy this prompt. It doesn't have to be any complication here. It's a simple post request. And it should receive the answer and display it on the screen. And basically just realized, as we can see here in the logs, well, basically you're right, there should be no streaming procedures and so on and so forth. Again, probably what I expected, it just over-engineered these practices. I already asked a question, what's the Microsoft revenue? It came out with all these particular correct numbers. And once we again shoot the final time, the execute workflow component, I'm asking again this particular question that we had before. It is then looking for the particular answer. Again, retrieval, augmented, generation. Now the generation is actually happening. And again, we see perfectly being displayed. The fiscal year was 49.1 billion, which represents a 26% increase compared to the 38.9 billion. It's exactly what we have seen here for 49.1 billion. It's exactly the correct output. Once again, the user could be asking multiple questions on this document. And let's quickly also check if the RAG agent, not just for my own curiosity, is also able, with a simple configuration, to be basically saying, what is the total revenue of Microsoft? Not particularly this very high level number, because that seems to be a little bit too easy. I'm interested in the LinkedIn revenue for this particular company, or any more complicated revenue number. So let's go back to the highlights quickly. Let's look for a more complicated number as opposed to just the top revenue number. Let me quickly see. We can also be asking, for example, what are the short-term investments as assets in the balance sheet? Simply put, what are the short-term in the balance sheet? And we probably have to specify the year as well. It's September 2025 by September 2025. And let's see if it is capable to actually also be looking for tabular data. Sometimes it might be a little bit too difficult. It basically says September 30th, the balance sheet amounts to 73,163 million, 73,136. That's the correct answer also for the table data. Once again, the investment analysts might actually be asking some more complex questions, for example, on some more specific financial numbers on the models, for example. Why don't we ask, for example, when did the Irish Data Protection Commission matter actually happen? That's maybe the last question. Might be some legal question that the analyst is going to ask. In what year did the Irish Data Protection Commission matter actually happen? Once again, we wait for the trigger, we send the message. It does go look into the PDF document, which is now semantically put in 2018. That is the correct answer. So this stuff is working, and we would also be at the end of the tutorial. We took a little bit of back and forth. We're at V7 of Versal V0, but just high level what we build is a retrieval augmented generation system with a front-end component that's fairly sophisticated, just the way it looks. Again, 7 iterations. We can now balloon that up to 100 or 200 iterations, more features, more LLM integrations. We also build a fully functioning retrieval augmented generation pipeline using Supabase as a vector storage, OpenAI as an embedding model, and also OpenAI's chat model to then basically be doing the brain work of taking the question, going into the vector storage, and retrieving that particular information, displaying it back here in the UI. That's it for the tutorial. It took a little bit longer than I expected because of some agentic AI capabilities here. But still, if I added value to you, please feel free to also drop a comment and like the video. If you have a question, maybe what tutorial we should do next, definitely do that. And again, on this channel, we have the podcast where we again deep dive into building components, also building some technical elements. And at the same time, we have these tutorials where we talk about all things using Versal V0 and A8N, and especially also going into the future, some more custom engineering topics. So in that said, see you in the next one and take care. See you in the next video.